everyone, here are the solutions to review sheet number 3. The majority of these were application type problems, so I want to take some time to go through these. The first one is talking about fencing, and it says there's 1,800 feet of fence available to build 5 adjacent pens. You can see that in the diagram. And it says to express the total area of the pens as a function of x. So there's a couple things we know. It says to express the total area. We know that area is just length times width, or x times y. So we know that for sure. But we also have some other information. This 1,800 feet of fencing, that's the all the way around, and then those pieces on the inside. So if I add all that up, that would be 2y plus 6x has to equal 1,800. And it says to express the total area as a function of x, meaning I want to represent the area in terms of only x, which means that here I just need to solve this equation for y. So I end up with 2y plus 6, 2y is equal to 1,800 minus 6x, and so then y is equal to 900 minus 3x, and so then we can express the area A of x as x times 900 minus 3x, and if we distribute, we end up with 900x minus 3x squared. So that is the function. And then the second part says, what value of x will maximize the total area? So if we're looking to maximize, right, this, if you were to graph this, it's a parabola that opens down, and so we're looking for that maximum. To find maximum, all we have to do is negative b over 2a. So if I say negative b over 2a, then that would be negative 900 over 2 times negative 3. So that would be 900 over 6, which comes out to be, or negative 900 over negative 6 comes out to be 150 feet. So if x is 150 feet, it says what value of x will maximize total area. So that's the second part, is 150 feet. The last part says what is the maximum area, and so we can go ahead and substitute in to our function. So basically a of 150 is equal to 900 times 150 minus 3 times 150 squared, which comes out to be 67,500 feet. Okay, so pretty straightforward, but that's what you have to do. You need those two equations. Okay, problem number 2 is talking about a hockey team, and they play in this certain arena. They've got 15,000 spectators. Ticket price is set at $14, and the average attendance was recently 9,500. So they did this market survey, and it says that for each dollar the ticket price is lowered, the average attendance increases by 1,000. We did similar problems to this when we were talking about airplane tickets and passengers and that kind of thing. So it's the same type of problem as that. So part A says to find a function that models the revenue in terms of ticket price. So revenue is going to equal our ticket price times attendance, right? So however many people attend times the price is going to be our revenue. Okay, so if we let x equal our ticket price, let's see, we want to R is our revenue, so we want to find R of x. And the other important information we have is this 9,500 people and this $14, and all of that. So let's kind of put that into mathematical terms. Our ticket price is X, right? Our ticket price is X. We know that the ticket prices are lowered by a certain amount of money. We just don't know what that is, okay? It just says for each dollar that the ticket price is lowered. So we're going with 14, that's the current price, minus X, okay? The attendance increases. So our attendance increases every dollar we lower that ticket price. And so our attendance then is going to be 9,500, that was our original amount, plus 1,000 for every dollar that we lower it. Okay, so that is what our attendance is. Our ticket price is X, so our revenue, R of X, is just going to be our ticket price times our attendance, 9,500 plus 1,000 times 14 minus X. And I'm going to leave you guys to do all the math there and distribute and combine like terms, but you do end up with 23,500 X minus 1,000 X squared. Okay, so that is part A, that's your function. So part B says, what ticket price is so high that no one attends and hence no revenue is generated? Well, again, this is a parabola, right? And if X is our ticket price, so we're trying to find where we have no revenue. So basically we're looking for this point here. So when revenue is 0, what is X? That's what we're doing. So if we set this equal to 0 and solve it, that's what we have to do. So we have 23,500 X minus 1,000 X squared is equal to 0. Right? So we know that that when X, we can factor out an X, right? So I'm trying to just find where I have more room. X times, we can actually, let's see, we can take out 100, so we have 2350. Well, you know, I'm just going to leave it like this for now, just because I'm trying to do this so I don't run out of time. So X equals 0, and then 23,500 minus 1,000 X is equal to 0. We know that X is 0. And then we solve this for X. So subtract 23,500 from both sides and divide by 1,000. We end up with 2350 would be the price that would cause nobody to come to the game. Okay? And part C says the price that maximizes ticket sales. Well, we know how to do that already. We're just doing negative B over 2A, and when you plug in your values, you end up with $11.75. Okay, so also not too terribly bad, relatively straightforward on that one. Problem number 3 is talking about direct variation. So it doesn't say it exactly in words, but hopefully you can determine that from the way the problem is worded. So Nicole is looking to get the position in sales. It offers commission. It says that her earnings depend on the amount of her sales. So if she sells a vehicle for $4,600, she will earn $736. So if she sells a vehicle for $4,600, she will earn $736. But what is that percentage? Right? We're trying to say, well, what percentage of that gives us the 736? I wrote that wrong. So 4,600 times some percentage has to equal $736. Okay, that's what we're looking for. And so when we solve that, we end up with 736 over 4,600, which I believe comes out to be about 16 percent. Let's see, 736 divided by 4,600. Yep, comes out to be 0.16. Okay, so about 16% is how much she earns on every vehicle she sells. So that's direct variation. So if you think of this as y is equal to k times x, right, this is our constant of variation, which is 0.16. So it says, what will her earnings be? So if y is her earnings, if she sells a car for 8,600, well, if I just do 0.16 times 8,600, that will tell me how much she's going to earn. 8,600 times 0.16, and that gives us $1,376. Okay, so first we had to find the constant of variation. I probably should have called this K. This is our K value. That's our K value. That's our constant of variation. Okay, and once we found that, then we could go ahead and figure out what the other amount was. Okay, let's see if we can fit one more problem in this video. Water temperature in an ocean varies inversely. So this one is telling you exactly what kind of variation it is to the water's depth. Between the depths of 250 and 500 feet, the formula is given. So T is 14,000 over D, the depth. It says, what is the change in temperature from 500 feet to 2,000 feet below sea level? So all we're doing is finding this. Now in this particular problem, it gave you the formula. I probably wouldn't give you the formula on the test. Remember, inverse variation means as one increases, the other one decreases. Okay, so you can think of it as this. T times D is equal to 14,000. So as one of these numbers increases, the other one has to decrease in order to keep that constant of 14,000. That's all that inverse variation is. So we would figure this out for 500. And if we figure that out, 14,000 divided by 500 gives us 28. So 28 degrees Fahrenheit. And if we do the same when we are 2,000 feet below sea level, that's pretty far, then our temperature would be, that would just be 7 degrees, right? 7 degrees Fahrenheit. So your difference then, what is the change in temperature, would be negative 21 degrees Fahrenheit. Okay, so that's pretty straightforward on those. I got a couple more problems for you, which will be in the next video. Thanks, guys.